Hello, hello. What day is it? Nobody knows. I think it's Thursday. April 9th. I've just dated myself. So we're humming along. We've got multiplication, division, addition, subtraction. We're understanding how these things all come together. I want to do an example of a long string of things to see if we can figure out what that looks like. Okay? And then we're going to go on to variables. New coffee. This is a running store on France Avenue in Edina, Minnesota. And I just know this is their logo, and I, for the life of me, can't remember the name of the store right now. But you'll find it. I have a t-shirt like this, too. Okay. All right, so let's try a little something, something, shall we? All right. I'm going to make something up right out of my head. All right. This is going to be our example. Okay, I'm making this up. This is of just simplifying. Okay? Let's just think about all the things we've learned. So this is a number. It's also a division. It's also an operation. That's what fractions are. Okay? So we got 3 divided by 4 times 5 divided by 6 times 12 divided by 9 plus 2 divided by 3 times 6. Well, that's a mess. But I do know one major thing right away. This addition separates. This is going to become a whole number, this is going to become a number, simplified number. I don't know if it's whole or an integer or a rational yet. This is going to become a number. I left out subtraction. You're welcome. But so that means that we can batch all this together and we can batch all that together. This is going to be infinitely easier, but whatever. Okay. It's not just because there's 2 terms and there's one that's a whole number. Let's think about this, okay? Now, this commutative property, multiplication, means that we can move things around. This begs the idea of factors, which I did say we were going to talk about, didn't I? That'll be the next lesson. Then we'll move on. So this begs the idea of factors, okay? But before we get into factors, let's just organize these into an easier way. So I'm seeing that 6 divided by 12 becomes a whole number. So I'm going to move the 6 there, and I'm going to move the 9 there. 5 can stay where it is, and the 4 is going to be just, the 5 and the 4 are just going to be a mess. But I'm going to rewrite this way. 3 divided by 9 times 5 divided by 4 times 12 divided by 6. Now, I'm allowed to do that because this is one big division altogether, and these are all multiplied. So what I actually did is I used the commutative property on the denominator. Now, you can use a calculator and plug all these in and get these things, and you're going to get a decimal. But what if your teacher, like me, says answers need to be in a fraction? Sorry! And I do it every time. I do. Because you miss the lesson if you put it into a calculator. Calculators will always just put it into a decimal, which our system is base 10, deci. That's fine if you're an accountant. But you're not an accountant. You're learning math. This is very fundamentally different. So why would I have done this? It's actually because, and it's again this factor thing, I know that 9 is what? 3 times 3. So what I can do is I can reduce this. Can we reduce that? We need a lesson on equivalent fractions. Backwards Becca needs, I'm going to go, in the future Becca's going to do past Becca. Equivalent fractions. That's a note to past Becca. Gonna go back in time. Well, so then we'll know from our equivalent fractions that can be reduced to 1/3 because these both have a 3. This has to stay the way it is because 5 and 4 have no factors in common because we learned about that already, remember? Back in time. Okay, but 12 divided by 6 is actually a whole number. What is it? Did you guys say 2? I'm pretty sure I heard somebody say 2. You said 2. Okay, it's 2. But I'm going to write it as 2 over 1 so we know that the denominator, or the numerators and denominators multiply it their own ways. Now over here, we can do the same thing here. I guess I go right here. 2 over 1, because 6 is like over 1. And we're going to learn that here when I do this in the future, but in the past. Times 6 over 3. 6 divided by 3 is, you betcha, 2. And this is 2. So now we have this whole big thing. Well, let's combine them, shall we? We can multiply all the numerators. This becomes 10. Oh, wait, no, I can move more. Do you see these? they also have a common factor of dos. So that becomes 1, and that becomes 2. So when I simplify that, I get I have 1 times 5 times 1, which is 5. And I have 3 times 2 times 1, which is 6. Plus 2 times 2 is 4. 5 over 6 plus 4. Now we have what we like to call a mixed number. We could change this. This is going to be repeating. We could change this to a decimal, but I already told you I don't want that. So I want you to either make this into 6s, which we won't do right now, or we'll just leave it as a mixed number. So you should know how a mixed number goes together. A mixed number is actually the implicit operation is addition. So when I write 4 and 5/6, what that means is 4 plus 5/6. And that's my final answer of this mess that I made. It wasn't a mess. So we need to talk about equivalent fractions, or we're going to. These are skills that we had to do this. Equivalent fractions, knowing our factors, and finding a common denominator. So those are lessons we got to do like pronto right now. All right, have a good one. I'll see you in a bit. That was 8 minutes long, but most of it is me just being like, hey, how's it going? How you doing? All right, okay. Happy quarantine. Day 20. I predicted 60 days, so we got to be in it to win it. All right, good luck, everybody.